In this video, let's try to understand what exactly is a linked list. A linked list is nothing but a linear data structure. That means all the values that we have inside that linked list are basically arranged sequentially one after another, and whatever the value that we are having inside the linked list, right, they are basically created at the random memory location. Since they are basically getting created at the random memory location, we might need the access of that value in our implementation, right? Since as they are getting created at the random memory location, to get the access of those values, whatever the values that we have, each and every value will basically have a specific link or connection with the next value that we have inside the linked list. For example, just take the singly linked list that I have here, right? Here in this singly linked list, as you can see, we have 5 values, and the first value, the value 1 is available at the at this memory location. Similarly, the value A is available at whatever the memory location that you are seeing on the screen. Similarly, false is also created at a random memory location. Remember that these memory locations are not sequential. They are basically getting created at the random memory locations. To have the access of that specific value, each and every value we have in the linked list will basically have the connection with the next value that we have in that specific linked list. It is since that connection is nothing but link to the next value. That is the reason why we call this data structure as a linked list. Okay, remember that. And here I'm explaining on a singly linked list, but remember that based on the way we are arranging the values, based on the way we have the access to the next and previous values, and based on whether the linked list is circular or not, there are types like singly linked list, doubly linked list, and circular linked list. Those are something that we will be discussing in the future, but here we are trying to understand what exactly is a linked list. Linked list is a data structure in which each and every value we have is created in the random memory location, and each and every value will basically have the connection with the next value, so that we will be able to read any value we have inside that specific linked list. Okay, that is the simple definition of a linked list data structure. Why we are basically creating the values randomly in the memory, right? That is something that let's just try to understand. Before we came onto this linked list, right, we basically have a concept of arrays. In the case of Python directly does not have arrays concept in it, but Python gives a simple list data type, right? In that, whatever the list that we have, all the values we have inside that list are basically ordered. That means all the values are created in a sequential memory block. That's the reason why we can simply use that list itself as an array in our implementation. Okay, as we have that arrays concept, right, whenever we talk about the arrays, all the values we have inside the array are basically created in a continuous memory block. For example, let's just say I want to create an array that can basically store 5 values. That means based on the data that I'm trying to store in that array, first of all I need to find the continuous memory block that can basically store all the 5 values in a sequential memory location. That's the reason why this is a disadvantage, right? Because whatever the data that I want to store might be very huge. That means we might not have a sequential continuous memory block to store all the values. But whatever the combined memory that we want for storing all those values might be available in a specific places inside the RAM. That's the reason why, as part of the linked list, what exactly we will do is these values will basically be created at the random memory location, and each and every value is connected to the next value. Basically we'll have a connection or link with the next value, so that we can basically add as many values as we want till we run out of memory. Okay, basically we are eliminating the continuous memory block requirement in our scope, and we can simply reuse any of the freely available memory that we want for creating and storing the values. That is the purpose of linked list data structure. Now let's try to understand whatever the linked list that we have discussed previously, right? Let's try to understand it as an abstract data type. If you are hearing the word abstract data type for the first time, right, abstraction is nothing but setting up some rules or higher level blueprint that we will follow whenever we implement that specific data structure. Remember that abstraction is nothing but setting up the rules and principles that we follow while implementation. So the very first rule that we have for the linked list is basically supporting the heterogeneous data. For example, whatever the data that I want to store as part of the linked list is nothing but I might store some integer values, I might store some boolean values, I might have some string values, I might have some custom object that I might want to store as part of the values we have inside that singly linked list. That's the reason why the very first fundamental rule that we have for linked list is supporting heterogeneous data. Here, whatever the linked list that you are seeing here, right? If you see here, we have different sorts of data. We have value 1, which is a number. We have value a, which is nothing but a single character. And we have value false, which is nothing but a boolean value. Here we also have a floating point value as well, and we have some string also in it. That basically shows that whatever the linked list that we are going to implement is supporting the heterogeneous data in the storage. Okay, and the second property is basically allowing the duplicates. In the case of linked list, there is no restriction on how many number of times each and every value can be stored in its values. For example, whatever the linked list that we have here, right? Now, for example, let's just assume that here instead of a, let's just assume we have value 1.23 as well. Now, inside the linked list that we have, 1.23 is available here and 1.23 is available here itself. And if at all, if user wants to insert once again 1.23, they can go ahead and insert this value any number of times. Besides this, if I want to insert the value hello also once again, I can insert that value also into my linked list. Basically, there is no restriction on how many number of times each and every value can be stored in it. That is the second principle. And the third principle is preserving the insertion order. That means that whatever the order that I'm inserting the values into the linked list, the order should be preserved. So here, whatever the linked list values that we have here, right, it shows, it is preserving the insertion order. That means here the first value we have inside the linked list is 1, right? That means in my implementation, when I added the value 1 into the singly linked list, right, I added it in the very first insert operation. And whatever the 1.23 that we have here, I inserted it after 1. Similarly, whatever the false that we have, I inserted that after 1.23. That means whatever the insertion order that I'm inserting the values into the linked list, it is basically preserving that specific order. Okay, and the fourth property that we have for implementing the linked list is supporting the null or none values. Remember that here null is for the people who are learning it using either Java or JavaScript, and none is for the people who are implementing that using Python language. Okay, you have to follow the respective representations based on the programming language that you are using for implementing the linked list data structure. Okay, that means if at all I want to insert some null or none value in it, inserting that value is also possible. And since we are going to allow duplicates, this value can be inserted any number of times as well. Okay, so the next property that we have for linked list implementation is nothing but supporting the null or none values in the storage. Okay, so those are the properties that we will follow while implementing the linked list data structure later in the future. Remember that whatever the linked list that we implement will basically support the heterogeneous data, and it will basically allow the duplicates, and it also preserves the insertion order that we insert the values into the linked list, and it will also support the null and none values insertion as well. Okay, so that is the linked list as a abstract data type.